Okay, hello. Today I'm going to give you the keys you need in order to check your experiments and your data to tell that you have reliable data. So just take your notebook, take your pen, pencil, or whatever you have, because I'm going to give you 3 keys, easy peasy to understand, in order to get reliable data. In any experiment you have, you should require, or you're gonna need to talk about reliable data, and I'm gonna give you the 3 main factors to talk about reliable data. So let's go. I'm going to give you the example of reliable data with an experiment. So you may ask, okay, what will be the experiment? You decide. So the experiment is quite simple. Imagine that we're going to measure the time that a ball, okay, this is a ball, takes to move a given height. So we're going to do an experiment in which we're going to determine the time relation between the height of a ball, so height and time. That's the experiment. And let's say that 2 people, John and Mike, okay, did the experiment, did the same experiment, but John just dropped the ball, measure, and he noticed that the measure was, let's say, 1.303 seconds. Okay? So we can say, okay, John, that's nice, but there are many factors that John is not taking into account to take the data, because if you give it just one trial, you don't know what is your reaction time, or you don't know if you solve or you put your your ball in the same position all the time, or maybe you don't let drop the ball at the same time. So John is giving you just one answer that it has many mistakes or many data or many errors inside that we cannot predict. However, Mike decided to take 5 trials and take an average. Okay? So Mike is including with these 5 trials all the possible mistakes that we have because of the experiment, like the reaction time, like the way you drop the ball, or okay, many other factors that you can take into consideration. So the first factor you have to take into account in order to get reliable data is to take many trials, if possible, of your results. Okay, this is one big idea to have reliable data. Why? So what is that the thing between many trials? If you take many trials, you will have 2 excellent results. The first result is that you will have an average of the data, and this average is the value you're going to take at the actual value. Okay? You're including all the errors. And secondly, we can find the uncertainty. Uncertainty. The uncertainty is going to be defined as maximum time minus minimum time divided by 2. So in this way we have the uncertainty and the average. Okay? So many trials include and help you to have some error mistakes that we include in the experiment because of human errors. Okay? So first factor, many trials. Now, what will be the second factor? Let's say that, yes, we did many trials, okay? But when we apply the many trials, we found out that the time, one of the times is 1.03 seconds with the uncertainty of 0.20 seconds. And in the other case, we have 1.03 seconds with an uncertainty of 0.01 seconds. So in which case, let's talk about John and Mike again. So that will be John and that will be Mike. So what do you think is the most reliable data from these two factors, John's or Mike? Okay, so look at the problem. The problem is that we have the same data with different uncertainties. And our question is to know who's better, who's getting the most reliable data. So we just need to watch the results and we'll see that the most reliable data is found for Mike's because the uncertainty is smaller compared to the data than in the case of John. So the second factor to check reliable data is to have an uncertainty small compared to the data. Okay, that's very important to have small uncertainties. Usually, if you have like some experiments at home, we can say that 10% is a good result to have an uncertainty. So if the uncertainty is 10% of the value, so it's good. But if we want to do a better experiment, the best will be 1%. If you can have uncertainties less than 1%, that the uncertainty is 1% of the actual value you're using, you have an excellent experiment, you have reliable data. But if you have like homemade experiments or experiments at school that are not so sophisticated, it's good to have less than 10% or less than 5%. That's good to ask your teacher that tells you like, what does he think about it? Okay, so the second factor to have reliable data is the uncertainties. Remember, first, many trials, 5, 10, 15, 20. If you have a lot, that will be excellent. Second, uncertainties, small to the data. And now we're going to check the third factor that I think is very important to test reliable data. The third factor to test reliable data is calling the okay, I'm going to show you with this example. So let's say that John again is going to throw the ball. Okay, from this height. And Mike, okay, let's say that John throws the ball from this height. And he's going to change this height, these points, like these few intervals. And Mike decides to do his job using a height starting from this height and increasing the height more. Okay? And secondly, John decided to throw the ball with a velocity that he cannot measure, and Mike decided to just drop the ball in order to start with a velocity that is approximately equals to 0 meters per second. Okay? So, who's doing a best experiment, easier to measure? Look at that, John is taking smallest height, okay? So it's difficult because of the reaction time to take appropriate numbers if the height is very small. And secondly, he's throwing the ball. He's getting a speed, so it's more difficult for him to get a quite good value of the time and the relation between height. If you left it just like Mike, drop it at 0 meters per second and increase the height, that will get you a better idea of how to get the results. So Mike will use reliable data. So this third part is related with the independent and control variables. So always in an experiment, when you're measuring, try to use control and independent variables that help you to take the data properly. Okay? That really you can use to take data. That your reaction time or the human mistakes could be decreased because of the independent and control variables setting properly. If you set, for example, in this case, higher distances, you will get better results because your reaction time is not going to be taken into account when you include more distances. Okay? And if you left it from speed 0, so it will be easier for you. So these are the factors to have reliable data. So let me repeat to you: many trials for the same experiment, uncertainties, smaller compared to the data, and use appropriate control variables. So I hope that this video helped you to understand how to do experiments and how to improve in physics, chemistry, and biology labs. See you the next time. Bye bye. Follow me on my social network. Bye bye.